Hello, welcome back to CSCI 310. So we'll keep continuous during the spring break. We stop by the those like virus and we will continue about the computer worms. So this will be another type of like virus, semi retreated for the computer. So what's the property of the worm that compare with the virus or trojans? So for the worm is a program that will like copies itself from one computer to another. So it's mainly and when we start with the origins, so it should be like some like they should be the computations. So they should be connected to the networks like physically wireless might be possible, and then maybe doing or some possible like animations, some broadcast a message. So they will sending out. And how is the format they send out is through the segment. Okay, so they will treat it as a parser program. So they will copy them to other workstations, devices, and those segments we got like a segment process data. So they will communicate with the ROM's controller. Okay, so that means that we should have a controller maybe with that will already injected. So we'll connect the controller. So we'll send it out. Okay, communicate to others. Okay, and any activities on those like workstation also can cause those like segment to shut down. Okay, so here's the property of the computer ROMs. And it's just a pretty long history, so you just like need to know. So it would be okay. So it's the target is the Berkeley. So it's some Unix system. Okay, so they just use some like virus-like attack to inject certain instructions into the running programs and run them. If they need to recover it, so they have to like really disconnect the whole systems from the internet and then reboot of them. And you will see always like after they being infected, like auto system, we need to prevent reinfection. Okay, because like, if we don't remove the cause, then it gonna be like infected one more time. So we do have like several critical programs they have to like patch and then we compile, we install. So we do so it's really time consuming. And then also like analysts have to like disassemble it and then have to like uncover the functions, all this. And this when they disable for several thousand systems in like almost like 6 or so like hours. So that's really crazy. And we have more, but coming for some examples, if you're interested, you can look into it. But I'm not going into details. So for example, we have the IBM, so including the electronic letters instructing the recipient to save it, and then they will once it's a program. So nowadays you maybe not really receive any like all the e-letters like they will do the like Christmas tree and then put the Merry Christmas. Okay, so when they do that, actually in behind they mainly they will check your address book, and they will try to list also all these like previous received email and send a copy to each address. Okay, so it caused the like the shutdown of several IBM networks. Okay, so really so we call it a macro ROM. Okay, so they will written in the command language so they can like interpret. Okay, so it's like kind of working this way. And in the structure, when we talk about those like ROM, of course, including that one is called the target selection. So they will determine which system to spread to. So if you remember, like give you some sample code, like in the lab, I saying, okay, we try to determine which system. So we check the OS. So here's the first step, and then propagation. So they will try to attempt to infect the chosen target. They will copy itself right to others through the internet. So they will search and in behind they were looking for some possible open ports, and then when you click on it, they will inject it. Okay, and we have a status called execution, and the execution stage will be like carry out certain actions. So after they become, we say the resonance on the target. Okay, and also it's possible that this phase may be empty because for worm is like copy itself, but it may be not really taking certain action. Okay. And we have got another ones that called the internet worm or the Morris worm too. So how it works. So first we try to choose some the target from the list of the trusted hosts. And those trusted hosts by the user, so they will have some maybe host like password. So they will have been like guess. Okay, during the propagation, so they will try to expose like for vulnerability first, like they will try to check the like SML. So maybe using the SMTP cipher. The SMTP is the protocol like for sending the email, right? So for in the debug mode, and then we have the fingerprint. So it's the information server. But for they try to like do the overflow attack, and then they will use some like guest password. Okay, they will check like sending the guest password, and then they will try to expose the like trust relationship. So all this, and then during the execution stage, so what they doing, so they consider is like presence, and also they can prevent the reinfection. Okay, and also they try to like guess the password on the local system. Okay, so if they're using in the target selection, or this like during the and Stanislavski, this one is like founded in 2010. So one example, say they try to target the Siemens. Okay, you know, one of the brand popular. So for this one, it mainly try to how it works is try to compromise the Windows software first. Okay, so it's like including the PLC, and then they first sophisticate like in the versions like expose and using in the first PLC the rootkit. So if you remember the rootkit using, and then they sponge them and then non-standard speed so they can like the tore apart. And also they can enter the system like through different infected, like let's say USB stick. Okay, so with the Trojan horse. So you see one thing in the example, sometimes they're working together. So you're not saying, okay, if just a computer wrong, everything is just wrong. But also like they always like mix with other type of virus or like Trojan horse together work together. So they will try to look on the local network for the window base. So here's a reason like while we're checking for the OS, if you remember like what's the system, and then to infect, if we found, so they will infect no more than 3. Okay, that has to work. And then on the system, they will like try to check and see if they are like it was a part of a specific industrial control system. So if no, they just do nothing, and then yes, add. So they will perform something. And all these we say no matter wrong virus, their behavior is that they will try to check, okay, doing detection first. And if they didn't meet certain criteria, okay, status, they probably they will like destroy themselves. They won't take certain action. But once they meet those like requirements, then they will perform certain action. So like this. And so far keep going on. So they will like just like try to download more like current version of itself. And that's like how it most of the time like all those virus, if you have a chance taking the mail and access, so you will see more applications like how those like infected application, like how they really like try to download like taking some commands. It's pretty similar behavior. So they will try to take the control of it. And then also they believe like maybe they were more than one or more nation state. So due to its complexity, okay. So you see, it's not that simple. And when we learning all these different virus like possible attack, okay. So actually they try to expression nowadays. So because the defense system, okay, the levels is actually getting more like advanced. So they are more like complex sophistication, okay, and we are more like that. But just to make it really simple, we always emphasize like earlier research showing that like the physical system, the ability to attack, is therefore always from the connected computers. Okay, so really like physically connected. So what you get from the graph, like maybe stacking, and then you see like they try to looking for the here's the stage. Okay, so we call the weaponization targeting. Okay, and looking, and then they will start through the delivery, and then they will expose, and then they will like install it. So in this stage, and then sometimes if you want to, they're working together. Finally, when they really install something, then they will like here's the step you are like able to observe. Okay, and then we'll move on. Sometimes we have two second stage will be we call the ICS attack. So they will including like some like develop or like testing and deliver. And then also they will install or modify certain content because they sometimes they try to pretend or hide self. Okay, so they will delete the original one, or sometimes they will create some like virtual process or like the virtual thread. Okay, so under the original process. So that's how it looks like. and then they will execute the attack. Okay, and another type like after the children is brigade and then warm, and another one is the bot. Okay, so here will be a structure. So the bot will be the malware. So they will create some like action in coordinate with other bots. Okay, and then we always have a bot master exist in this bot network. So the attacker will control the bot on one or more system. Okay, so they can be distributed, and then we have the called the command and control CNC server, including the mothership system, the mothership, the bot master. So they will send a command. There's a one application doing in the mail analysis. It will showing is like once you have an internet connection, and then they will try to check the connection first, and then if you do have a connection to the internet, they will try to create a exe file. Okay, after they create exe file, and then they will listen to the port like to the master. So if you sending certain command, let's say if you send IP config, or like you want to list all the contents, then they will receive all those commands. Okay, so this one is the port master and saying to the other kind. So for the CNC channels, they will have a communication path. So using for it, so they will using specific port. Okay, and then it can be distinguishing the characteristics of the bot. So it's like using of this channel. Okay, they're possible to be triggered and then update over this one. Okay, and when they connect all this together, they try to infect of these like computers. We call the zombies. Okay, so they will, we call something like the botnet. So we have collection of the bots. Okay, so this one. If we go like slightly more deeper about the bot on the botnet, so it will be like including the step to like infect the system, and then they will check the network connection, and then they will see either if the CNC servers or other bot can communicate with, and they will try to get the comments and send by the server, okay, or from other bot. Okay, of course they can add other components or other bots doing, so it's really flexible, and then they can execute this command once they receive it, and then can send all these results out to somewhere else. So really depends on this one. And based on the if you want to look at the organization of the botnet, so including the centralized, okay, so each bot communication, they will directly connect to the like the CNC server. Okay, and it causes the potential problem is the CNC server may become a bottleneck. Okay, bottleneck, that means that because so many connections, if the bandwidth is not enough, the processing power is not enough, they may let slow down. Okay, and if you look at the hierarchy of this, like the botnet, including the CNC server, so they'll communicate with a set of bot, right? So maybe it can like in turns as a CNC server too. So this not really say, okay, if I'm the bot or client join me, also they can turn into the CNC server. So in like just like hierarchy. Okay, so if you're good, like really good, like if you really have a large botnet, and then you can control like multiple layers. So you just imagine it's just a tree structure. Okay, so multiple. Okay, and also we can do like as a peer-to-peer. That means you're not required the CNC server. Okay, so those bot can act as peers. So we can call it the peer-to-peers botnet. Okay, and but it will have some like latency. Okay, because you need to join the botnet, scanning each other's, find each other's to forward the message. So it would cause that latency. And GTBot is another one, is centralized. That means we have the master, so it will show once you get on the Windows system, so it will run an MILC client, it will install the script. So they will try to monitor the channels and looking for some specific keywords. And also it will try to hide the bot. Okay, so some other program will propagate the bot to other systems and install it on the too. Okay, and one of the example, like if one of the instance try to install it, and then it will hide self, and it will notify the attacker, okay, through the channels. So it's ready. So This one we can have lots of different tools once we already inject the bot. So you can send all those command to the our those like zombies. Okay. Here they mention the topic. So it's the hierarchy structure. So it's based as the rootkit. So it will install itself. So we execute as a at the boot stage. Okay, so in the boot state is like so after when the BIOS will loading into the memory, so before the OS loaded, so they will connect to the server, so get the modules and add it. So they will compromise some sensitive data like the password, okay, and then they will send it back to the server side. And when they will have a server acknowledgement, so they will just upload it. So they will also like send files to the with the address of the backups server too. So those will contact as like a server too. Okay. And then and another example is they call the peer-to-peer. Okay, so they using the peer-to-peer protocol to connect each other. So they may be for the address at least maybe like 100 of peers can store in the bot. And then they were looking for some like value encoding. So here's the idea like no matter like different type of architecture or like structure, we try to looking for certain content and then point to other components, and then we try to download and execute this component. Okay, and more like possible component, like including maybe for like spamming or some like ripping emails address like for spam or some like launch and disappear the DOS attacker too. So they're all possible doing as a peer-to-peer. And the content delivery networks and the IP first can be like we're talking about the content delivery network, including Netflix, Amazon, all this, because they have there's so many servers, okay, in different location, okay, so they are invisible to the client, so they only know say when they access to the Amazon, the DNS, maybe the load balancer, they will handle. Okay, so if the DNS get the target system, so they will return the IP address to the client. Let's say we are located in Texas. Okay, in Texas we do have a data server. Okay, so we are nearby, then it can increase the speed. So when this network grew, so we need to have a way to prevent any single server being like overloaded. Okay, so including the mechanism to change the IP address, like associated with some particular host names. So over some short period of times. Okay, so this one is called the IP flush. Okay, so where traffic really like go to really one particular system, so it will actually send to where the server have edges like currently. So this one is like working in behind. So we sometimes we got a connected delivery network, okay, or something. So when you see the terms like CDN or something like we using the different type of like load balancing mechanism. Sometimes we call the round robin taking terms like shortest times or at least use. Okay, so all these are possible mechanism can be applied. And when we apply this to the botnets, so it will what's the target, what's the goal? We try to like really hard to locate the bot. Okay, so especially like for the server, like we're using for the CNC server. And the approach is try to associate all this IP address with the host name. Okay, so of course it's possible to change all these associate address. And they also try to do the IP first botnet. They will change the binding between the host name and the IP address. So they will going down the list. We can do one is called a single first botnet. So they will list the IP address. So it's large. Okay, and then the host name is registered to one of these address. So after a short time, deregister and re-register using a different IP address, so they can keep on switching. And for double first botnet, so they will do the same, but just like the IP address of the DNS server, and then use it to like look up that IP address. So it's called a double. Okay, and also it can call the like fast reference botnets. Okay. Another example right here, so we call the frame. Frame is the example of the first botnet. So it will give us some information from the infect the system or this network, and we can like retrieve it over the CNC channels to the server. Okay, we call the frame server, and then we can send a new modules for the part. Okay. Once it's being installed, we will check the network. So we try to connect to all those like well-known servers. So if they're all success, so let's say if we have 5 domains that initially for the server, and then server can add more to this list. Okay, so they can like communicate through the SSL. Okay, so they will have a self sign. So if you see the HTTPS, the S we say the SSL. So they will preliminary the NSS. So they may have more than like 50 host name, more than like 15 IP address related to the CNC message. Okay, so later they can reach up higher, it goes up to 100. So you see, it's really hard to check it. And also we have that called another one is your domain. Okay, so instead we're just holding the host name and then fixed it and changing the associate IP address. Then they think, how about we change the host name and keep the associate IP address fixed? So what's the differences? Okay, so if you know the concept about some networking, so let's say we have the text domain name, right? And then the server, so we have an IP address. So before it's like, okay, I have the same domain name, but I try to like associate this domain name with different IP address, like different actual locate device, or we say the nodes, right? And for this time, we try to change the domain. That means like the DNS. I can have a same device, same IP address, but have different name for it. Okay. The advantage is that when the host name associated with the server can be like just a short period of time. So when we need to do the IP first, and we need to find the host name identifier of the CNC server. Okay, so for the topic, the example we came, so maybe they will compute a host name. So with a fixed like with number, sometimes appended like .com, .net, .nz, like of the suffix. So they will like pop for each. If not, they maybe generate the name based on the current data, some servers like this. If given knowledge, then we try to put some fixed list of the host name. So here's the flow. Okay, so the first one, second, third. Okay, and one of it is called the rapid. Okay, so rapid so is will absorb all the this a program, so they will absorb all the some classes of resources. Okay, for the Unix system. So if you see right here the shell command, so when through they will do it, they will try to make the directory and change directory and done. Okay, so all this they will try to exhaust the either the disk space or file allocation table. Okay, you see it's pretty simple, but it's a infinite loop. Okay, while true, always true. So it'll keep running. So it take all your process power, and they only take in 2 things. So in this example, you will see is like how important is even just a 2 simple commands create directory, make directory, and then child your directory, and that's it. But it will already cost you like exhaust all your disk space. So you see, just like simple commands, but it can cause a huge issue. So it really depends on how you apply those commands. Okay, and then once got the logic bomb. So for the logic bomb is the program, so they will perform an action that like violate the site security policy. Okay, and then when some like external event occurs, so here's the some like coupon of the logic bomb. And one of the example is a program they will delete the company's like payroll records. So if one particular record is deleted, okay, so they were searching for one particular record. So they usually maybe the person they writing this type of logic bomb. Okay, so once they're being deleted, and ideal case maybe let's say the employee like they know they got being fired, and then they will know the payroll record will be deleted. So that one is the one like how to like let the logic bomb export. Okay, so they will let the commit lose all other records. Okay, they will delete all. And pretty common this one you see is the adverb. Okay, every will be good like work for the children's house too. So they will try to gather your information for the marketing purpose, and then they will try to display the advertisements. Okay, so I think most of you will pretty familiar with this one. So they often select some ads to display based on your like gather information, and also we can like calculate that we have their own originated with some like company like Anasit. So they'll make the software available for free. So you see lots of they pop out for free. You click on it, so they will pop up those like Windows advertising company. Okay. Maybe they will like the user they have like opt-in and then they will spread through the like distribute their program on it. So it's possible when you download some programs online, sometimes you will see a lot like and it comes together. You maybe when it pops out, then you can install. Okay, and what are the possible like um behavior like those types? So we have some like called the low server behavior. So it can just like display the ad, so they didn't um, transmit any information. Okay, so most of the time, so if you're lucky to have those, and then for the medium therefore, then they will try to transmit the information like the low risk, maybe some your location, okay, or some then they can display some like ad based on this, like if you know where they are, you are, and especially we need to pay attention is the height. Okay, so they will transmit your personal information, sensitive data, and then they will display the ad like tailored to the device. So they will people maybe those like some characteristics. So they're really kind of like annoying. We say very aggressive. Okay. So we sometimes we call it as a malware too. Okay. So if I know maybe you are just let's say I know your information or like when you just purchase a vehicle, your car. Okay. So I will just like keep popping out like the maybe you have some experience like pretty similar. So they pop some like auto insurance or like body shop or like this. So all this information. And when they try to get the advert on the system, they always like putting on the website. So you always we say you will see the banners on top of it, you will click and banner. They will try to confuse you. So if you ever see some website, they will say, okay, click on this, download this. So they will request you to download some software. So you allow. So if you pay attention, sometimes when you click on the buttons or like click on the banner when you download you see the files it looks so weird. Okay, then you they maybe those free software maybe contain the everywhere. Okay, and the page they sometimes will refresh automatically and they will redirect to some like the browser to run the executable, that means the binary files. So usually when the bounce are late, they will notify the user. So for the dialog box, they require click on the program. This is one time I can share like when I reinstall my MacBook, as I say, and then I have to install the Adobe Flash. Okay, this is a pretty long time ago. Okay, it's required, but suddenly it pops up. I have to like update. You say, oh, okay, but because at the time I just reinstall it. Okay, so I know maybe I need to update. So it costs like maybe becomes download the executable file, it took all my processing power. So that's what I realized. Okay, they are just like trying to inject some system or application on my computer. Okay, sometimes there are no indication. So okay, so they were like could drive by downloading. So you have no idea. So they just like put in download. Okay, and then execute file automatically. So you have to like really aware and pay attention to it and just keep going. And sometimes they will like put a software like for the user to download pretty common like if you know for mobile apps, especially in the Android market. So they're really like well open. Okay, so they will ask you for permission. Okay, to create some tasks. Okay, some maybe then like unnecessary, or like maybe for some if as like after the course or like kind of like educated, they will know okay for some um permission. Okay, actually we can let's say have a minimum set. Okay, but you need to know, but they just like request more. Sometimes they want to access your camera, microphone, or like let you make the phone call with because you know like some application like get your permission access the camera, they can record it with the notification or microphone, they can record your voice or like they can use it to dial. in like they can make a call without the dial interface. So you never know you're making a phone call. Okay. So that's why we talk about the Android apps. Okay. Sometimes there are free games like for some application app like something get it for free. So they will like attract the user to download it. Okay. And then of course the in behind we have something called economic motivate. And those like target ads can be held most likely to like respond to like maybe they're making get more money displayed on like click on it. So the website owner can display the app on their stage, or developer can put the like app library in the app, and also they can take the app modify and then put them to unauthorized app store. This I always see a lot. So you see some website, especially some Android apps. So you see the APK format. Okay, so those APK they can be modified, and they will inject and maybe some games they will put the advertisement banner. So they can modify. Okay, and after we talk about the area, then we have the called the spyware. Spyware will be the Trojan source. We try to record the information we are used for the computer for the third party. So they usually result in like compromise confidential information, including your keystroke. That means they try to record the pattern or like looking for your passwords, some critical information. And those information will be stored and then for retrieval or sent to the third party. So they will have some channel gateway. So they will send back to the server. So when they put on one server, so they maybe like go to others, other system by other malware too. So it's possible through the worm, Trojan horse. So it's possible. And you see the how we distinguish or like how can we categorize them? Sometimes they looks pretty similar, but just like based on the purpose. Like let's say for spyware, we really target on the confidential information. Then we call it a spyware. Okay. And here's a one of example, like try to getting the control of the iPhone. So they were sending the HTML file to exploit vulnerability. This being the risk, and then those that will be on the Safari. And after they download the software, they gain the control of iPhone. And they will try to cipher some like different keys for each handle, and then they will try to include the loader for the next stage too. So when the loaders like try to download some dynamic load library, okay, or daemons or other software, and then they can install this. Um, before long time ago, they still the iPhone allowed jailbreak. If you know jailbreak, that means they try to get the root control. Okay, and if they have root control, be a long time ago for the old version of iPhone, maybe like before iPhone 7 or before iPhone 8. So you can do the jailbreak. Okay, so you can get a root control because once you have a root control, you can access other folders. Okay, on the iPhone system. Okay. So it can then they try to remove all of the access to the iPhone. So one for example, and how can we like Apple respond? They try to develop a patch, okay, to fix it, okay, cover it. So try to update, and when they discover when the human rights like activists like receive the text message with some subscription link, they say okay to the citizen lab, and they recognize the name associated with the manufacturer spyware for the government surveillance. So they would like look and cover some technical analysis. That's like how. And next one will be pretty common if you see like we call the ransomware. Gonna come, and I think like all of you are working on the assignments or looking choosing one of the or maybe most of you or some of you are choosing ransomware. So ransomware, the malware will be like interpreted using the computer resource then until the ransom is paid. And pretty famous one, they try to because the ability of the Windows system, so they have a backdoor, and they try to encrypt your hard drive, okay, your storage. So they will post out um, the screen. So ask you like if you want to unlock your storage, then you have to pay like by the Bitcoin like this. Okay. So it's a pretty long time ago, and this one is the crypto lockers. So they will try to encrypt the files and then give the victims 100 hours to pay the ransom and know that crypto key will be destroyed. No matter how old ago or like you see the history, okay, so pretty similar. They just change the way they always looking for the vulnerability of the system, and they try to encrypt it. And then if you don't pay for it, they won't unlock. So it's pretty similar. And it's one of the example protocol. So like maybe they if they want to like let's say they want to generate a asymmetric key pair. So later you will learn it in the cryptographic, and they will try to embed the public key in the malware. So they will need to return the private key. Okay. So let's say those are malware infect the system, they will try to generate a symmetric key and use it to encipher. That means they try to encrypt it. Okay. So once they encipher the symmetric key with the public key, so they will erase all instance of the symmetric key. Well, no, maybe you have no idea what's the asymmetric or asymmetric, and then the symmetric key. Okay, asymmetric key, that means that it's the same key, but asymmetric, that means they use the public key and the private key. So later we will tell you. And then they see the message, and then they say, okay, they need to do something like pay some money. If you don't do that, they will maybe include like encrypt the symmetric key. Okay, so doing this, if you pay, then they will like decipher and encrypt the symmetric key. So with the private key, so we turn it. So actually, this one is the you will see they use it for ransom, but also we are using it for the encryption. Okay, for increasing higher cybersecurity. So depends how we use it. And next, we'll talk about the phishing. So phishing will be like actually like the impersonate like extremistic entity. So you say in order to obtain information, so such as the password, credit card information without authorization, so like this. Maybe sometimes website or sometimes you'll receive some email. So they will try to make some like fake their profile website, so look like the like official one. Okay, and then they will send lots of emails trying to like some like pressure like people to do something okay on it. And they say okay pretty common if you have you ever received like maybe from the UPS, FedEx, USPS, okay, say okay you have a package with some like the parcel, and then have some issue like please log in and check, or like maybe you have maybe let's say you have some certain coupon credits, you have to do something, please log into the account. Okay, so once you try log in using your username, email, password, or other information used later, then they can copy all this. Actually, in the emails, so they can be like when you try to type, so they will really pass your data to the real website. Okay, and then send the reply back to you. So we call the man-in-the-middle attack. So it's another one involved for phishing. That means you're thinking that when you're typing all the information in the fake website, those fake website will send all your information and credit information to your really real website, and then return it. So you never know. They are like in the middle already steal all your bank information. Let's say they ask you to log into a bank account, they can like use the information to log in a bank account, and they return the bank account information to you. Maybe in the first time you didn't realize it, but they already obtain all your like bank log in information. They can log in later and transfer out all the money. Okay, and here's the example they'll say in the bank, and then we have some like the server phishing. So they would like to phishing attack like tailor for the particular user. Okay, so maybe we have some specific user we want to obtain information from them, then we will call this name. Okay, so maybe some employee of some like major cybersecurity company, they will receive it to 2011 recruitment month plan, and then they will open an attack spreadsheet. Okay, so they will expose some vulnerability in the supporting like programs. So they will install backdoor, so attacker can control the system remotely. So this is how it looks like for targeting. And also the theory of the virus, we always asking, okay, so is there any single algorithm to detect the computer virus? Actually, we say need to think. We need to define what's the virus, first like the turning machine, or also we need if we can match those like haunting pop-up in those like algorithm. So I think then that means like, is it possible? Maybe really hard, right? And also we have some general results like theory. So if it's undesirable, whether it's the arbitrary program connect some malicious logic. So it's right here. And differences right here. So we can try to like doing some scanning and try to distinguish between the data instructions and like containing that means like how can we check it? And then we're looking for some specific behavior and try to limit certain sharing, and then we can do some statistical like analysis. So all these can help us to defense it. Okay. Of course, when we dive deeper, so we know how can we looking for some specific behavior or like some containing what kind of things like URL, certain action. Okay, do they what kind of certain keywords? Okay, behavior. All those are possible instructions. Okay. For the scanning defense, if we say so, they try to alter the memory contents of the disk file. So maybe they will try to compute the kind of manipulation protection code (MDC). So we try to generate some like signature to block data, save it. Okay. So later maybe we can be compared to MDC and compare the original one. So if it's different, that means the data has been changed. So that's how the scanning defense works. And the tripwire, so is how it works is called we can use for the files system scanner. So in the initialization, we'll compute the signature for each files and save it. So like all these have a checksum. So sometimes we say what the MD5 sum SH1, SH256 for this checksum. And then when we need to check the system, we just run it. Okay. So they will regenerate the file signature. And then we compare the new generated signature with, and then the report if there's any differences compared with what we saved before. Okay, but we do some assumption is that the file itself originally doesn't contain some malicious logic. Okay, when the original signature block they already generate. But here's one example: if in the beginning they already been infected, and then you save it, and then when you regenerate again, the report will say, okay. So here's will be like, say if the subject can execute a program with the credibility rating is greater than the risk level, then if the rating of the credibility is less than the risk level, we can use some like specific commands to run the program. Something like this, it may help. Okay. And then we have some like antivirus program, always say no. So we have the malware signatures. Okay, so if we find that we want it, so one of website we call the virus total. So if you think, or so you can do it by yourself. Okay, when you upload a application, and they will like compare all the libraries. They will check the signatures. Like sometimes we say the MD5 sum or the SH1. So they will match with these signatures. So they will have some like static sequence of bits or patterns like of those. Of course, like if when we we will dive deeper in the malware analysis, but in this stage, you just need to know like for those malware, there are certain patterns of behavior, okay, or like in those code, and then they will like different like these have like manually. Then later they will use they will done automatically. They will like install the application, connect to their server, and then like perform certain action. Okay, so it's possible. And here's one of the example. It's called early bird. And the early bird lets system will generate the worm signature, and then based on the worm increasing the network traffic. So they're between the hosts, and then this traffic maybe some like common substrings, right? So when the package arrive, so the contents like hash and then destination port and the protocol identifier appended on it. And then next step, they will try to check the hash table. Okay, so those table they will see, okay, if this content, okay, maybe the port or protocol has been seen, yes, then they will increase the counter from the source, and then including the destination address. If both of them they exceed the threshold, the content may be like could be the wrong signature. So this how we did it. If no, then we can one-to-one multi-stage filter, so they can have four different hash, and then check those like hash in different tables. So they will count like do they what's the smallest count incremented. So of those like four counters exist the second threshold, then maybe we will make the like the entry in the dispersion table like this. Then we can find several ROMs before the anti-malware vendor display the signature for them like this. So this one is the mechanism of how we call it early part, right? So we try to do it figure earlier. And then we have the polygraph. Okay, so and then with polygraph is assume the form they are like polymorphic or like metamorphic. Okay, so they will generate a class of signatures. So all this will based on the substring. So based on we call it token, and we also have called a construction signatures. They will collect all these like substrings, those tokens. They will try to match all those tokens. So regarding the orders, and also another one's the token subsequent signature. So pretty similar to conjunction, but they will need to like in order. So one's conjunction signature and token subsequent signatures. And called a bias signature association. So they will have a score to like all for those like tokens, and we giving the threshold with the signature. So probably the probability of the payload. So we're going to compute based on the token score. So like this, if they exist the threshold, so they will maybe matched. Okay. Based on this experiments like this, so if they're actually more than 80% network traffic, so but no one's like identified, it's really like not really helpful way. And then move on, we have the behavioral analysis. When we running, so we will try to suspect some suspected malware in some like confined area. Normally we try to create a sandbox, okay, virtual environment. So we try to simulate the environment. It may be going to possible, and then monitor it for some certain period of time. And if something maybe looking considered bad, then it occurred that's effect showing some area. Because some virus they will wait. Okay, so after execute it, they will maybe setting certain timer and checking. Maybe they will try to execute in the midnight, or they will wait for maybe 1 month, 2 months. They will execute it. Okay, so but nowadays there are some malware they already try to detect is the sandbox or it's a virtual environment. If yes, then they will try to delete itself. So they're not going to execute. So it will increase the difficulty for the behavior analysis. And one of the example right here, so we will telling you, so if we try to load the unsuspected malware into a Windows system, so we load into a parameter and then run it. Okay, so the file belonging, so they will try to suspect the program. So they will test the engine. So they say that we can send some like sensitive information to some trusted application, and then they will like change the engine. So they will monitor the flow of the information of our system. So when those like suspected program enters the application one, so we check those like behavior information. They will if they were can in the graph. Okay, for the malware detection engine, so they analyze those graph for the suspicious behavior. Okay, so this one when they test it, maybe like 42 malware samples, and then 56, and most of them they will say no false negative and 3 false negative. If you see the terms that was like false negative or false positive, that means that suppose it should be negative, but it turns the positive. Okay, so that means, and then or like it should be negative, but it turns a positive, then they will call it. Okay, so if it should be positive, but it give you a result is negative, that means like false negative. Okay, and then we move on the inventions. So they will try to ensure the malicious activity they are not triggered in the NS environment. So they will try to wait for some long times, as we say, and then they will wait for particular input or external event. Later, they will try to identify the mail is running in a constraint environment. They will check, okay, and maybe we'll try this group this table, and we will try to run some like sequence of instruction. So we will see if they're generic or not in the virtual machine, somewhere in the beginning, we'll say. And we talk about the data and instruction, right? So data is a content, instruction is the some execution with first statements we try to do. So for those malicious logic, so for the virus, they try to return to the program, the data, and then try to execute. So they will move if in low level, so they move the content to the register, okay, the register, and save it, and then they will execute or move a jump to certain condition, and then create files like this, have a system call, function call, and then they will return the content. So those approach will be treated data and instructions. So as a separate text, and they request a certified authoritative approach like those conversions. So those key can be like will be certain assumption they will be like certified authority, so they won't make any mistake. Okay, also assume the truth they're using those infrastructures, they won't have any corrupt. Okay, so of course we do have some. One of the example we're using is called log. Log will be the some like logical coprocessor kernel, so it designed to like certify it. Okay, and then when they try to compile the program, so as a type of data, they will have a sequence like specific auditable event. So we try to like change those type to like executable, and they will also make sure that those like can't modify executable objects. Okay, so the virus cannot like insert those to those programs. Okay, so there are no infection phase. So it's called a log, how it looks like. And one of the example like showing you this diff as a Unix. So if the user try to execute the permission, okay, user has some like with permission. So if a file they will have the execution, right, execute permission, and then they have executable. So without it, it's just like okay, it's a we call it data. Okay, so if the executable files they can be like alter, so but the type immediately change it to data. Okay. So this one we like implement by some like turning off the execution permission. So only the certified so can change them back. So it can make the virus that can like spread only if they run as a certified. Okay, so it will increase the difficulty. And also with like containments, and so with the bias about the user, so it may be only execute some malicious logic. Okay, so they and then they will execute with all the user privilege. So we try to limit the accessibility object. So they should like limit the spread of malicious logic and then effect to its action. That's why maybe you learn like what's the least privilege rewrite execution. So that's why how can we do it? Okay. So those approaches can just the mechanism of the confinement. Okay. And keep going on. We have some information of the flow matrix. So this one, the idea is that we try to limit the distance of the virus that can spread. Okay, so how it looks like let's say we define called flow distance x passing it. Initially, all the information have distance 0. So whenever the information is shared, so it will increase by 1 plus 1. So whenever just like it from the beginning 1 to n, so we compute one. So to get the z, so we try to get the maximum value. Okay, so if the information x accessible, so if only some parameters, let's say we have a v, so we should be less than v, then we can control the flow of it. Okay, so let's say we're giving maybe let's say for any would be 3, b and Kathy will be 2. So if let's say they create a program contain virus after execute, so they will start like in the beginning. Okay, P will be have a distance 0. Okay, so it's still for B is 2. So if we send it from program Q, the distance because +1 is still less than it. So it may allow, but Kathy will execute Q, so it will try to write to Kathy program R, right? But it will fail because like when the distance is 1, and then when it goes to out, it will be 2. Okay, so here's the problem: if the Kathy execute P, so maybe out can be infected. Okay, so it may be after infected, then it may be kind of a new program. After new program, then the system will be like changed to 0 again and then +1. So it can, so we does not really stop the spread, but it just like slow down quickly like this. So you see it looks weird, but once it's being infected, it will change the distance, the flow. Okay, and of course, it kind of like when we try to like implement it, we do have some issue on it. So the vector may associate with the information, so but not the object itself. So when you try to take the files or the metric, and then how can you take the information on them? So it's really hard. So maybe inhibit during the sharing. If you want to stop the spread, okay, so don't let it just change the video 0. Then you just disallow all the sharing. But it's just defeat the like purpose of multi-user system, because we like right nowadays we share all the information, so it's really hard. So right now we need to know in reality we have to share information, so we cannot set it to 0. And then when we go to like reducing the protection domain, so we always apply the principle of least privilege. Best idea, we move all the right from the process, so it can only perform as a function. Giving warning, so the function required it to write, it can run by anything. Okay, so you need to make sure it only write only to the objects you are expecting. So that's like more important. Okay, and here we have ACLs or like series. So including, so let's say S1 owns the file F1 and the S2 owns the program P2 and files F3. So if S1 can read by F1, okay, and then execute P2 by F3, and then S2 can read by execute P2 and read F3. You see right here, this pretty similar, like when I giving assignment that related to the permission by file. So they give me example. So if let's say S1 need to run P2, so you know like S1 need to run P2, and P2 connects to the host is malware, right? So S1 may need to like ensure like P12 right here 12 will be like created, because this one like S1 run P2, but it cannot write to F3. So right here. So ideally, so when like P12 right here, they will have a capability. So we have the S1, P2, and X. So X will be like something we don't know. So it will be like no problem. Okay. But in actually by practice, P12, this one right here, we inherit the S1's right. And so it can write to the F3 right here. Okay. That's not good. Okay, really bad. So try not that's why I say do not try to own F3, but you can actually change the way over F3. So that's why. So maybe we need to restrict the access by others. So it's a better idea. And how do we check? And we sometimes we try to give an authorization denial subset. So we define like each user like SI. So we connect the ACL entries, and then others cannot like exercise over like subject like what it owns. So let's say we have S2, okay, it owns S1, F3, and right, okay, right here. So if let's say P1 to try to like write to the F3, and say P1 own the by S1, okay, but you remember, and the F3 owned by S2, so the system denied the access. So if you remember right here, because the like file 1 and S2 own the program 2 and file F3, right? So that's how we work together. Then here's a problem: how can you decide which one should be like authorized denoise subset? This one is a hard question, and then we need still need to think about it. Okay, and another one we can introduce like for the protection. So it will be the concurrence scheme. So it will based on the attribute of the subject or object. So we can like interpose as a knowledge base of subsystem. Then we can determine if the required file access unreasonable. Okay, maybe we can say between the kernels or application. So one example is the Unix C compiler. So they will try to read the files. So name like .c.h. So C files or like the header files. Then they try to write the files. The name begin with the temp, CTM. Okay, and those like assembly files will be like ending with the .s. So when there's a step involved, so if the C compiler they try to write the C file, then they will reject the request. So it will be better, right? And light and gray is another one. They will try to implement just like based on this schema modify. So they will allow the program to access and read or write the files like named on the command line, but they will prevent the access to other files. Okay, and there's a two type of process we can do like trusted. Then we have no access check or restriction. But for untrusted, then we need to like try to give a valid access list control. So they will access, and also when they initialize, they will have to command line arguments. So also they need to pass some and like temporary files to that like process creates. Okay, so they can be, and then for the file access request, we want to be like if they're fast on the VAL, so we call that the valid accesses, and we can use some effective like UID or the GID. Okay, UID or user ID. So of the process to determine that if their access is allowed. If the access request is like maybe read and the file is like raw readable, then you may allow to access one. If the process try to create a file, but those are UID, GID control is allow creation, then yes, they will enter files into the VAL. So as I know, new node arguments, they can set a permission so no other process can read it. Okay, so then they'll ask the user, okay, in a command, so yes, then those like UID and GID will control allow access. No, they will deny the access. So this one you see, like this an important step you see, it will ask the user, like, okay, is it allow the process to do that? Okay. And here's one example. If the assembler try to involve from the compiler, so they will try to access, you remember the temp files CTM. Okay, then they want to create the temp files like this, and in the list, like VALs, where there's access list right here. So they were checking the temp files. Okay, so if the Trojan horse want to copy the access to another files, so once they're on creation, so the files in accessible to or like unexpected creating the user, so like they cannot like read it. So it's a rule number 3 right here. So when they create, they will check it the VAL way. So to read the file, and if the file declaration created already and assembler try to write to it, then they will ask like the user like rule number 4 right here, yes or no. Okay, so they will able like to stop it. And of course, we also have some like trusted programs. So if we have no VAL apply here, so they will command like CSH shell sh, like then the program can spam them. So they will like get or log in, and the programs can access the file systems. You calculate like AR, change group, change all these command line. Or sometimes they can the program access files not in argument list like the mails like CPP, like DBX and mail right here, Mac file like script. Okay. Also some various network daemons like the fingerprint or like FTPD or like send mails, all this can we would call it. And then for the virus or malwares, they will try to target on those programs, and then they try to attack this too. So if we have some trust program, then we become their target. Okay, but for later dive deeper, then we will learn more. Okay, how we change it. And also we have some like called the guardian or the watchdog. So we will try to like intercept the request to open a file. The program they will try to involve to determine if the access to if they allow. So we can have some guardian or watchdog. So they will check. So we can effectively like redefine the systems like the library call. So they will check it. And then the trust, so the trust will be able to users to take explicit action, so they can limit their process protection domain sufficiently. So there's like they try to enforce the least privilege. Okay, we're using a trust mechanism to describe program, expect some actions sufficiently for description like to be applied, okay, and try to handle the command without such like description properly. So there's like the, and those like trust specific programs and kernels will be we're going to do, but there's a problem. So usually the first program like will be a malicious logic attack. So it's a possible way. So if you have a first trust program, but they already been getting attacked, then what should we do? So it's a still a risk. And then one's the sandbox. So sandbox is actually using the virtual machine. So we have all restricted away under protection. So when they try to modify the program, insert certain instruction, they just like cause some traps away. So when they violate their policy, and they will try to replace dynamic load by libraries with the instructional routines. So all these, and we try to call what is called race condition. So here's the term for the race condition is that it will going to occur when there's a system like cause operate an object. So if the calls like try to identify both the object and the names, they will try to rebind the names to different objects between the call. Okay, so for the sandbox, they will have some instrument calls. So that in the beginning first call, we have a unique file identifier. So I call the unknown saved. When we have second call, so the unknown of the name file will compare to the first call. So if they are different attacker, so maybe like anyway. So like this, it's called the race condition. You know that which one go first, and then compare it. And by the next, and the specification, so it's related with infection. So in the execution phase of the malware, so they will treat it as an error. So one of the example, we try to break the program into the sequence of non-branching instruction, and then we maybe have a checksum of each sequence, okay, encrypt it and store it. So when the program is run, the process will be recompiled and check the checksum. So each branch compares. So if compare pre-compute value. So if they're different, that means that an error has occurred. So that kind of like we change all these like into like sequence, get the like checksum maybe using MD5 H1 or SH256, and then when we try to execute, we check one more time. Because for some malware, they will only execute like we call it in dynamic. So they only occur when we try to execute it, change it. So that's how we can change. Okay, and also we can have something like called M version programming. So we implement like several different versions of algorithm and then run them in concurrently. Okay, so we can check intermediate result periodically. So if there's some disagreement, that means the majority wins. So how it works. So we do have some assumption. First thing is the majority program, they're not infected. If all the programs like being infected, that means we get the false negative. That means suppose it should be like possibly being infected, but it just says no, nothing. Also, it underlying the operating system secure. Also, for those different algorithms, they should have like enough equal intermediate result. Maybe like also infeasible. So like this, especially those like malicious logic. So you need to sometimes you need to check the file access, right? And also inherent sharing. So we will try to use separations and implicitly in the integrated policy. So let's say we're using a lock. So keeping the single copy of shared procedures in the memory. In the master directories, we try to associate some unique owner of each process. And each of those like user can list others user like first trust like this. So before we execute any of those like procedure, so the system will try to check if the user execute those like procedures, trust procedure owner. So they will try to check it first. So this one is like try to handle for inhabit sharing. And then we can also apply like multi-level policy. So we can put the program like in the lowest security level, and then all other subject at a higher level. Okay, let's say we have a property by abstract, we have like properties. So nothing can write to those program or access property, then anything can read it, or sometimes we can execute those programs. So we have like, let's say, trust like storage system. So all the executables, trust data can be stored like below the user region. So the user application can alter them. And then the proof occurring code. So we can have like code consumer, that means the user can specify some safety requirements, and then code producer, that means the author, will generate a proof like code. So we try to move those their requirement. So those proof will integrate with some executable code, and they can change the code in related the proof. They can do it. So those like binary equal the code and the proof we deliver to the consumer. And then consumer will try to validate the proof. They do that meets a safety requirement. Okay, so maybe the statistics on the broccoli like packet filter, so they proof like 300 to 900 bytes. So they validate just in around like 0.3 to 1.3 milliseconds right here. Because like for the start cost is too high, then when the runtime cost is considerably shorter, okay. So we need to think about this one, the trade-off. And also we try to detecting the statistical like changes. If the application, if you have some frequent program working on it, but statistical like analysis we show, okay, the code from the fourth person, so maybe the Trojan horse or virus, then other attributes is possible. We can be like checking those like more conditionals than is original, or looking for some identical like sequence of the byte. If they are not commented like to any library routine, or they try to increase the file size, so figures they waiting to executable, that may be possible. And then thinning, so we can use the instruction like detection system to detect all this. So it's all. And also we have the those like key points like perplexing problem. So how do you really tell those users asking like if they're not, or like what the user intended, or like maybe some strong typing list. So like separating data instructions too. And those we see the file scanners. So they may be checking those like change in files, maybe legitimacy, they may officially is already or maybe not be. And also those are anti-malware like agents try to scan the pattern of files or some like behavior, different behavior of executables, those binary. And also they should be updated like when there's some new virus. And you see always new virus come out, there's some new pattern that we are not able to recognize. Okay. And we try to like monitor the ATGs and CK framework right here. So there's a structure example, but if you're interested, you can look at it. And so far quickly we go through all these like drivers like and also what the possible protection and try to avoid. And that's it for this like long lectures. Thank you so much.